coordinate divided by r. The x-coordinate is -2. So you're going to put -2 here. -2 over root 20. What's tangent theta? The y over, sorry, the y over x, right? So what's our y? 4, and then over the x, -2. So our answer is -2. Just to give you all a little heads up, when it comes to these 6 trig functions, okay, in pre-cal, there are 3 ways we define it. The right triangle, which we've already done, this, which I'm doing today, and then next time we will have a 3rd way of doing it. I know it's confusing, but you should be comfortable with all 3. They should all make sense to you, all right? Sometimes one perspective is better than the other when you're looking at a problem. Sometimes another way of looking at it's better. So it just depends on if you're in Cal 1 or Cal 2 or, you know. All right, do I need to write the reciprocals of these or no? Cosecant would just be that flipped over. Secant would be that, right? Cotangent that? Yes? Okay. Does that make sense? I want y'all to see something. This new definition, yes?
So then for the tangent, for the -2, it really doesn't matter, right? If it's positive or negative?
What doesn't matter?
Well, the negative, right?
Well, yes, if that would have been +2, then your answer would have been +2. Right? So it does matter. It does matter that that's negative, not positive. And here too, I mean, right? Here, that negative needs to be negative. All right, what is it that I wanted? Oh, I wanted to show you that this new definition, I want y'all to see that actually everything we've done, everything we did last time with the right triangles, this makes perfect sense. So remember we did a triangle and we did SOHCAHTOA, right? SOHCAHTOA. Let's imagine that this triangle is actually centered at the origin like this. And this is our point, okay? That's our point. It's this picture, right? With the point, and I've drawn a triangle. Then I can say that the distance from here to here, that would be the x-coordinate of that point, right? Like if this has a coordinates x and y, this would be the x-coordinate, and that would be the y-coordinate. And then this hypotenuse, I could call it r if I wanted to, right? So what would sine of this angle be? What would sine of this angle be? It's still opposite over hypotenuse, right? Which is y over r, right? And cosine would be x over r. And tangent would be opposite over adjacent. So do you see it's the same things here? Did you all see it or not? The only difference is that now we're not fixed with the right triangle. We can actually go past 90 degrees anywhere we want. And what will happen is then we have to pay attention to the signs of x and y. Because sometimes x can be negative. Here, right? Like in this picture, x is negative, y is positive. But you could be down here, right? Then your x and y would be both negative. So we're going to do more examples. All right. Let's do another example. Find all 6 trig function values of angle I want to phrase this the same way the book phrases it. Hold on. Okay, yeah. Of angle if the point -3, -5 lies on terminal side. Okay, so remember that when we were defining angles, we said that when you define an angle, everything points out the x-axis. That's our standard position, and then your angle can either open up like this, that's a positive angle, or it can go negative, right? This side of your angle is called the initial side, and this side is called the terminal side. I'm just trying to remind you, this is the terminal side. So what I'm telling you is that we have this angle, and I'm telling you that this point, -3, -5, lies on the terminal side of the angle. So I want all 6 trig function values of the angle that I'm referencing here. So let's go ahead and try and draw it. I have an angle -3, here's -3, -5's down here, and let's just imagine a point here, right? The angle we're talking about is that angle right there, theta, right? That's our theta. I should put here, let's add to this right in here, positive angle. Because I could have gone negative and gone back this way, right? So by saying positive, I'm making sure you understand I'm talking about the counterclockwise rotation through there. With me? Everyone's good or no? Yeah? All right, so can you tell me what x and y are here? What are the coordinates of this point? Yeah, I gave it to you, right? So that's good, right? To use this, we need x and y, don't we? But we also need r. R is the only thing we don't have, right? R is the only thing we don't have. So how can you figure out r if I give you those two? You can do a little right triangle, right? Create a little right triangle as a reference for yourself. Think about what that would look like. If I create a right triangle, it would go back to the x-axis. I could do it this way, right? Like this. Do you all see that little right triangle I created there? If I look at that right triangle, and I just look at the distances, how long is this side? 5. How long is this side? 3, and then this would be r, right? And then you can use your Pythagorean to get r. Yes?
When we're making the triangle, are we always going back to the x-axis?
Oh, I always like to take our point and project it back to the x-axis and draw it. So I'll show you a couple of scenarios. If your point's over here, then of course your triangle is just that. If your point is in the second quadrant, then there's your triangle. If your point is in the third quadrant, then there's your triangle. Right triangle, right triangle, right triangle. If your point is in the fourth quadrant, there's your triangle. See it? Those are the 4 possibilities, really. What's r? 3 squared plus 5 squared equals r squared. So what is it? R is the square root of 34? Root 34. So 9 plus 25. 34, square root of it. Leave it like that. And that's it. This is just plug in now, right? I mean, this is really, once you have r, like you're in business, all you're going to do is just do the y coordinate divided by r, the x coordinate divided by r, the y divided by the x, and then all those flipped over. Is that straightforward? Who has questions? I'm going to give you the answer here. What's sine theta for this problem? Is it 5? Careful. It's the y coordinate, right? What's the y coordinate? Now, yeah, don't look at this triangle was only to get r, okay? This was only to get r. We actually need the y coordinate off the point. So this is -5 over root 34. Now the cosine. It's the x coordinate, right? Over the radius, root 34. And finally, tangent would be what? 5/3, because you're going to have a -5 over a -3. And negative divided by negative would be positive. So 5/3. Flip all these over, and you get the other 3, okay? Is this seeming like it makes sense? I mean, we don't want to overcomplicate this. All right, let's talk about the signs of these functions. Okay, that's confusing. That language doesn't make any sense. The signs of the trig functions. So look at the answers we just got here. Do you all see that the sine of this angle was a negative number? And do you see that cosine was a negative number and that tangent was positive, right? And then if you look at the previous problem we did, sine was the previous problem. The point was here. Sine was positive, cosine was negative, tangent was negative, right? Okay, so when I'm talking about the signs of the trig functions, I'm referring to positive and negative right now. Okay? All right. I want you to think about any angle, an angle in quadrant 1. We talked about quadrants already, right? Quadrant 1, I'll highlight it. This is quadrant 1, right? It goes forever in that direction, but that's quadrant 1, right? Let's think about all of the possible angles, or any angle you could think of in here. So I'm just going to pick an arbitrary angle by just picking some arbitrary point. There's an angle. This would have an x and a y. And then, of course, there would be an r, wouldn't there? The r is always positive, because r is always going to be the hypotenuse, that distance from here to here, right? So r is always a positive number. What about x? If you're in the first quadrant, what can you tell me about the x? It's positive as well. And then what can you tell me about the y? Oops. Shit. The y is positive as well, right? All of them are positive. Right? They're all positive. Which means, I should write it over here, when we look at our 6 trig functions, sine theta is y over r, cosine theta is x over r, tangent theta is y over x, and then the other 3 are just these flipped over, right? So if I tell you that in the first quadrant, r is positive, x positive, y positive, then what can you tell me about all 6 trig functions? They're all positive, always, right? If your angle is in the first quadrant, then all 6 trig functions have positive answers. So I'm going to put here, in this first quadrant, all of them are positive. They're all positive. Let's look in the second quadrant. What if your angle is somewhere over here? You'll have an x, you'll have a y, you'll have an r. The r is always positive, right? But what about the x this time? The x is, if you're in the second quadrant, you have to move to the left, don't you? To get to that point. So your x will be negative. Right? To get to that point, I have to go over to the left. That's a negative x value. Your y value would be positive because I got to go up. So now look at these. What about your sine? It's your y divided by r. Y divided by r. It'll be y is a positive number divided by a positive. You should get positive, right? So sine will be positive here? Yes or no? Y'all are looking at me weird. So do y'all agree sine of whatever this angle is will be positive? I'm going to put greater than 0. Is that all right? In this quadrant, sine will be greater than 0. What about cosine? It'll be negative because cosine is your x divided by r. If x is negative, divide that by a positive, you'll have a negative number. So here cosine of the angle will be less than 0, a negative number. And then what about tangent? Well, tangent is y over x, right? So y divided by x, positive divided by negative, that'll be negative as well. So that'll be less than 0. Now what about the other three, the reciprocals? They'll be the same as this. So whatever sine is, cosecant's the same thing. So if sine is positive, so is cosecant. If cosine's negative, then so is secant. If tangent's negative, then so is cotangent. Yes or no? Okay, so what is the only trig function here that's positive of these three that I put here? The only one that's positive is this one, right? That one's positive. In the first quadrant, they were all positive, right? Here, only sine is positive. We have two more quadrants to talk about. Maybe we don't have to go through it in much detail. What about in the third quadrant? What if you're down here? Your x and your y and your r. The x there would be what? Positive or negative? Y is positive or negative? R is positive or negative? Well, R is always positive, right? So over here, what's x? Positive or negative? Negative. What about y? Negative as well. So you got to go to the left and down. This is in quadrant 3. So they're negative. Okay. Then is sine positive or negative? Sine is negative because you're going to do y divided by r. So sine in this quadrant is negative. What about cosine? Your x divided by r. That's negative as well, right? What about tangent? That's positive, right? Because you've got your y divided by x. That's a negative divided by negative. That should be positive. So tangent is positive here. So what's the only one that's positive? Tangent. Tangent is the only one that's positive here. All the others are negative. Last quadrant. What's x? What's y? What's r? Is x positive or negative? Positive. Y? Negative, so you got to go to the right. That's positive. Then down is your y coordinate, negative. R is always positive. So is sine positive or negative over here in the fourth quadrant? I should have put here quadrant 4. Sine there is negative, good. That's your y divided by r, so sine is negative. How about cosine? Wait a minute, hold on. Is sine, yes? What's cosine? Positive, because cosine is your x over r, right? Your x divided by r. Positive divided by positive. What about tangent? It's negative because that's your y divided by x. That's a negative divided by positive. So what's the only trig function here that's positive? Cosine's the only one that's positive. So in summary, when you think about the trig functions, in the first quadrant, all the trig functions turn out to be positive. In the second quadrant, just the sine function is positive. In the third quadrant, just the tangent. And in the fourth quadrant, just the cosine. And that's a lot to have to remember. So we have a cute little way of remembering this. Some of you may have seen this before. I'll erase this. What you can do is a little thing to remember it is you draw your quadrants and then you put this. And think about it like when you an angle goes through quadrants like 1, 2, 3, 4, right? We read this, all students take calculus. All students take calculus. Just a way to remember it, all right? all students take calculus. So what this means is that in the first quadrant, all trig functions are positive, sine is positive, tangent's positive, cosine's positive. Just way to remember it. Me personally, I hate this thing, okay? Because for me, I like the idea that you can visualize the point and what the x and the y coordinate are, and then the ratio being positive or negative. Like, oh, I've got a negative divided by a positive, so this is going to be negative. Rather than some cute little saying. But it's up to you. If that helps you, good. Questions? All right, we got to keep moving. Next idea. The trig function values at the quadrantals. Do you remember that word? Quadrantals. It's been a while since we've seen that word. What are the quadrantals? Do you remember what those are?
On the line.
Yeah, it's on the actual x-axis, y-axis. Those are called quadrantals. So we want to know what the trig function values are at the quadrantals. So we have to look at each of the quadrantals. So let's imagine you've got your xy axis here. Let's take a look at an angle that would be on this first quadrantal. That means right here. That is an angle, right? You could look at that angle as being 0. The angle 0, right? Both the initial and the terminal side are the same. So I'm going to pick a point out here. Does that point have an x and a y coordinate? Sure, right? Sure it does. What's the x coordinate? I don't know, right? I don't know what the x coordinate is. So how about I just call it x? And then what about the y coordinate?
0.
It's 0. That we know because you're on the x-axis, right? You're on that first quadrantal. All right, now if you know that, then you should be able to give me all the trig function values. Oh, wait, we're missing something, aren't we? We get the x, y. What do we need? We also need the r, right? Do you know what r is? X. R is actually x, isn't it? Because the distance you go out is actually the same as the x coordinate. So this distance from here to here, r, is actually just x. And that's very useful to us. Do y'all see that? Because we don't have a triangle, there's no hypotenuse. It's just a straight line distance. So then what's sine of theta then? By definition, sine of theta is y over r. For us, what's that? 0 over r or x. How about 0 over x? Is that okay? Which is just 0. And doesn't that mean for any angle, like not any angle, wouldn't that have worked for any point out on this flat line? So what I'm telling you is that, oops, I need to change something. I messed something up here. I forgot to actually put the angle. We know what the angle is, don't we? This is 0 degrees. That's important, all right? This angle right here on this quadrantal, the angle is 0. And so as long as the angle is 0, sine will always be 0 because of this construction. That this will be x, and that the r will always be x, and that y divided by r will always be 0 over x, which is always going to be 0. So sine of 0 is 0. What? What did I say? Sine of 0 is 0. Say it again. Sine of 0 is? 0. What sine of 0? 0. Okay. You get to my calculus class and you don't know that when they take the yardstick to you. Sine of 0 is 0. You don't need a calculator for that. Sine of 0 is 0. All right? What is cosine of 0? 1. Why? Well, by definition, cosine of theta of some angle, right, will be the x divided by the r. But if our angle is 0, x and r are exactly the same thing, right? So this is x over x, which is 1 always. What's cosine of 0? What's sine of 0? What's cosine of 0? What's cosine of 0? Okay. What's cosine of 0? All right. What's tangent of 0? 0. Why? Tangent is y over x, right? And y for us here is 0, right? And x is, well, x, and 0 divided by x is 0. What's sine of 0?
0.
Okay. Have y'all seen Fight Club before?
We don't talk about Fight Club.
Good. All right. So there's a scene in Fight Club, if you've ever seen the movie, where he makes them promise 3 times. He's like, you promised, and you promised, and you promised, and you promised. The 3 times you promised me. So I've had you say sine 0 is 0 at least 3 times, right? Cosine of 0 is 1. We said that once. Now tangent of 0, this one is, you should know this, okay? And it should be automatic by the time you get to Cal 1. But these two need to be automatic as of the next time we see each other, all right? And now I see you again, so now you know it, right? All right, so that's it. First quadrantal, right? Now, very important, very important. The other, I have not, for the examples I did before, I didn't do secant, cosecant, cotangent. I didn't do them because all we said was just flip them over, right? This is different though. We have to look at these. So what about cosecant theta? Cosecant of 0. Undefined. Why? Well, cosecant, by definition, is this flipped, isn't it? It's this flipped. So is that undefined?
Yes.
It's going to be the r over the, I'm going to put it here, it's the r over the y, right? And I just erased the picture, damn it. Okay, this, I don't need a circle. So we were out here, here was our point, it was the point x0, right? So if we take the r, which we said was x, and we divide it by the y was 0, we are not allowed to divide by 0, right? We are not allowed to divide by 0, and therefore, this is undefined. Cosecant of 0 is undefined. Sine of 0 is 0, but cosecant of 0 has no definition because it requires division by 0. Have y'all ever thought about, or have y'all ever discussed why you can't divide by 0? I'll try and explain it quickly. We don't have a ton of time. Let's say we take a fraction, 1/4. 1/4, right? What this means is start out with the candy bar. Okay, there's a candy bar. I'm going to cut this into 4 equal pieces, and then I'm going to take one of them. Is that a visual representation of 1/4 to you? Yes? All right, now what if I say 0 over 4? That means I'm going to start out with a candy bar. I'm going to cut it into 4 pieces, and I'm going to take none of them. So how much do I have? I have nothing, right? So this is 0. 0 divided by 4 is 0. 1 divided by 4 is 1/4. How about the number 4? What does that mean? Well, that means 4 over 1, right? So that means what I'm going to do is I'm going to take a candy bar, I'm going to cut it into 1 piece. There it is. And I'm going to take 4 of them. So I'm going to have 4 candy bars. That make sense?
Yes.
Now we get to the question, what if I do 4 divided by 0? So I'm going to start out with a candy bar, and I'm going to cut it into, how? You have a candy bar, I'm going to cut it into 0. That doesn't make any sense. Do you see that? Like here, I'm going to have a candy bar, I'm going to cut it into 1 piece. Well, there's the 1 piece, right? Here, cut into 4 pieces. There are the 4 pieces. Here, 4 pieces. And then the top is how much I take, right? So I'm supposed to start with the candy bar and cut it into no pieces but I already have a candy bar that doesn't make any sense, and then I'm supposed to take 4 of them. So this is just a complete cluster. You know what I mean? My daughter asked me, I said something the other day about traffic, and I was like, this is a complete... Eat your little goldfish now. All right, we continue. What's the next one? Cosecant was undefined. What about secant? Secant of 0 degrees, right? Secant of 0 degrees is going to be 1, right? Because it's the x-coordinate divided by the r, but for our particular picture here, that's just x over x, so that's 1. Hey, do y'all see that? Maybe it's obvious to you now. When I was looking at sine of 0 is 0, right? Cosecant is the reciprocal. What's the reciprocal of 0? 0, 0, you can look at that as 0 over 1, right? What's the reciprocal of that? 1 over 0 undefined, right? Look at this number. What's the reciprocal of 1? Itself, right? So this is going to be 1. What about cotangent? What are your thoughts on cotangent of 0? Undefined. Because if you look at tangent, you can look at tangent of 0 over 1, and then when you look at cotangent, you try and flip it, and it becomes undefined. I said it a minute ago, you didn't have that reaction. I'm sorry. All right. That's only the first quadrantal. We have 3 more, right? We have 3 more quadrantals. So let's set the quadrantals up, and then I'm going to give you the exercise of figuring out all the trig function values on them. All right? So let's look at the second quadrantal, which would be like this. Straight up. Straight up, like this. And there's a point. What is that angle? What is this angle right here? What is that angle theta? What is it? 90 degrees. Okay, can you tell me about the x-coordinate and y-coordinate of any point on this quadrantal that goes straight up? What's the x-coordinate? 0, because you're on the y-axis, aren't you? 0. What about the y-coordinate? It's something, right? Y, let's call it y. What's the radius? What's the radius there? So the distance from here to here is y, isn't it?